group work 5 problem based on this chapter. Let's read it. An elevator filled with passengers has a mass of 1700 kilograms. Part A, the elevator accelerates upward from rest at a rate of 1.2 meters per second squared for 1.5 seconds. Calculate the tension in the cable supporting the elevator. Okay, then we come to the other parts a little bit later on. So we read the question. The first thing we want to do is to sketch a diagram. So let me sketch that this here is my elevator. Okay, so obviously suspended by some kind of cable. There's going to be a tension in the cable, and there's going to be the weight of the people, which is given as 1700 times G. Right, so don't forget you need to multiply by 9.8 meters per second squared to get the value of the weight from the mass. Okay, or if you make a free body diagram, these are our only two forces. So this is, let this be the center. This is my tension in the cable, and this is my weight downwards, mg. Okay. The elevator accelerates upward at a the elevator accelerates upward from rest at a rate of 1.2 meters per second. That means I must have a net force in this direction. Since my acceleration is in this direction, right? Remember, F net, vector quantity, it's the same direction as the acceleration. And it tells me that I have an acceleration of 1.2 meters per second squared. So I have a relationship between F net and that acceleration. It's equal to the mass, which is 1700, times the acceleration, which is 1.2, right? Let's make that point a little more obvious. So this is my F net. And F net is also the resultant of these two. So if I take the upward direction as positive, this is going to be tension minus the weight downwards, which is 1700 times G, 9.8. So I can solve this equation for T, yeah? And that's going to give me T as 1700 times 9.8 plus 1.2. So I took this term to the other side, yeah? It becomes positive. And if you work this out in your calculator, that should come out to be 1.87 times 10 to the power 4 newtons. Tension is a force, so it's going to be in newtons. So this is part A. Yeah? Part B, the elevator continues upward at a constant velocity for 8.5 seconds. What is the tension in the cable during this time? So if there is constant velocity, that means we have no acceleration. Right? Acceleration is rate of change of velocity. We have no change in velocity. That means we have no F net. F net is 0. Yeah? So my tension for part B must be equal to mg. Yeah? Since the F net is 0. So you just need 1700 times 9.8. And what does that come out to be? 1.67 times 10 to the power 4. Yeah? Part C, the elevator decelerates, which means the acceleration is negative, okay? 0.6 for 3 seconds. What is the tension in the cable using this deceleration? So you can solve again by just putting negative for 0.6. And it's done for you on the next slide. Okay, so I'm not going to go through this last case. The important thing to note here is there's a red herring in all these timings. You're being thrown off to think about the time, but time is really not a factor here at all. Okay, so time makes no difference. Let's proceed to the next slide. And let's clear all the writing so that you can see this. This is the answer to part A, and part B and C, right? So the acceleration here is negative. Okay, we'll stop here with this chapter. Remember to do your homework. Your homework's on every chapter in WebAssign. Do not leave it till the end. It's the homework that prepares you for the test. So you do need to get that homework done. Okay, thank you.